Okay, hey, today we're going to look at things called suspensions. Now, sometimes you hear the word suspension in schools meaning something pretty bad, meaning that you've been told you can't come to school for a few days because you've been naughty. This has got nothing to do with that, okay? This is to do with mixtures. Suspensions are a type of mixture, and if we look on page 29 in our SciPad, it talks about sawdust and water, which I've got here, which looks pretty gross, and I certainly wouldn't want to drink it even for a bit.
I would.
Awesome. So there's a couple of ways we can separate suspensions. And the first way that we know it's a suspension is that there's stuff floating on the top or stuff sitting on the bottom. It's all a bit cloudy or murky. A suspension hasn't dissolved what we call the solute. It just hasn't dissolved. It's insoluble. If it was soluble, it wouldn't be called a suspension. It would be called a solution. And we're going to learn about those next week. So suspensions are actually really easy to separate. Your blood is an example of a suspension, actually. It's got your red blood cells, your white blood cells, things called platelets, lots of water that is the solution for the stuff called plasma. And what they do to separate that into the stuff that they can use for blood transfusions and all that sort of thing is they spin it really, really, really fast, and it separates into layers. And that's called a centrifuge. So it spins it really, really fast. Now, we don't have those. We do have one in the college, but we tend to use it only for senior experiments. So that's one way we can do it. Our most common way in year 9, 10, and actually even as far as 11, and sometimes year 12, is filtration. And that's what I'm going to show you shortly. But the other one that's probably the most common in your everyday life is called decanting. And that's something that you guys probably do whenever you make pasta, whenever you have to boil potatoes or peas or anything like that. It's where you carefully pour the liquid off the top. And then you might put something in the way to be a barrier while you pour the last of the water out. So that first step where you're carefully pouring the water out into the sink or whatever is called decanting. So it only works if the solid sinks. Well, that's not going to work with my sawdust because, as we can see, the sawdust is floating and sinking and it's all murky through the middle. So we can't use decanting. We could use centrifuge if we had one available, but we don't. So what we're going to do is filtering. And the key parts of filtering are a funnel and some filter paper. Now, we don't always need a funnel. For example, your vacuum cleaner uses filters. It doesn't have a funnel, but it does have a filter normally made of paper. So that it goes in our funnel, we're going to fold it a special way. What we're going to do is first of all fold it in half and do a good strong crease on it. Then we're going to fold it in half again. And again do a good strong crease on it. Then what we're going to do, and hopefully the camera can see this clearly, is we're going to open it up there. So there's 3 bits of paper on the side and 1 bit on the side. And it makes a bit of a funnel. So hopefully the camera can see that quite clearly. And then I can put that in my funnel. And then I've got a conical flask in this case to pour my suspension into. Now when I pour it, I'm trying to get it to hit my filter paper but not spill over the edge. So I might want to just quickly replace that. And it takes a bit of time, but you can see the water coming out the bottom is not nearly as murky as that. So it's working. It's separating our mixture. Now the liquid at the bottom is called the filtrate. It's what we want to get out of it. It's the liquid part, the solvent, as it were. So this would be nearly pure water. It's not completely pure.
I'd drink it.
I still wouldn't. But if I boiled it, I would. And in the top, we're going to get sawdust collected, what we call our residue. That's normally the stuff we don't want and chuck out. Not always. For example, if we had sandy water, we might want the sand for some of its properties.
Or the salt when they filter out.
Now, that's an interesting one. Salt will go straight through because the holes in the paper are too big for the salt, but they're not too big for the sand. So if you had salty, sandy water, the salt water would be the filtrate and the sand would be the residue.
Don't they use oil?
You can have things like that as well. You can have filters that separate them that way too.
How do you get salt out of it?
Right, then how would you get salt? We'll do that when we do solutions because salt does dissolve, it's soluble, so it makes a solution. So I've done the one for sawdust, which is in your book. Okay, it's just a demo. You're going to do something pretty cool. You're going to take 2 solutions and mix them together. And they're going to go all cloudy to make a solid. It's called a precipitation reaction. You're going to try and get that precipitate, that solid, out using the same process. Okay, so your experiment is going to be sodium carbonate, which is just washing powder, a washing soda. So it's a washing solution basically, and a thing called copper sulfate. Now copper sulfate is not very good for us, so please, if you get it on your skin, wash it off immediately with lots of water. You're going to mix those together and they're going to make a new chemical called copper carbonate. Copper carbonate is insoluble, so it'll end up making a suspension. You're then going to use filtering to try to get the copper carbonate in the filter paper, the residue, and hopefully in the bottom you have a different solution. I won't tell you what it's called in the bottom. Okay, and that's all on page 29 of your SciPad.